Hello, hello. Oh, Quake clone. It would be cool to make. I mean, yeah. We'll see what I mean. Yeah, I was thinking something super simple. I mean, I don't know. We'll just build up, do something, test it, build up from there. So I don't even know what to call this. First 3D project. I just want to test the waters a little bit, and it's gonna be interesting because, yeah, I don't really know like about things like modeling. I mean, I guess you could use something like, I don't know, is Blender free? Or something like that. I don't know, Blender. I mean, there's also, I know there's like others that... there's one for Minecraft where you can make like voxel-based models. Blender is free. Cool. I want to make like... I really like kind of low poly kind of style. Also, I have no idea about, you know, animations, things like that. I know there's like things like skeletons and stuff like that. But yeah, let's just get a project up here. This will be interesting also. It's probably gonna be... I probably have to change a lot of things. Maybe even not start from the template. Maybe just do straight from scratch, maybe. Because really, a lot of this is based on like 2D stuff. Box 3D is available too. Oh yeah, physics is a whole thing. I think we'll leave physics out for now. I might do something with that later. I mean, it's probably just, yeah, Box 3D. Since I have some Box 2D experience, I guess Box 3D wouldn't be too high of a jump. Maybe, I don't know. Maybe, perhaps, we don't know. You finally switched to Zig and creating an Undertale balance system in it. Oh, nice. Oh yeah, because you were doing a Deltarune fan game, right? Or wait, someone made a fan game. I think someone talked about Deltarune. Anyway. Nice, nice. Yeah, I hope it goes well for you. If you have any questions, feel free to ask. I'll try to help as best as I can. I mean, I guess we can use this as a starting point. It does have some utility that we can reuse. I mean, I could just make like a 3D version of physics, of my like basic physics library, to just have some basic, you know, it's like an alternative to using a real, quote unquote, real physics engine. I mean, really, we could swap out like gravity, like this would be like a vector 3. I mean, I could just make, so I guess the easiest way is just to copy this, make it like physics 3D, and then in the end, if we see that, okay, we can kind of it's almost the same. It's just switching out 2D, 3D, you know. Then we can make it the same system and then just have an option saying, you know, it's like mode is physics mode or dimensions or whatever. And then this would be like, you know, is it 2D or 3D? Except you can't start with a number, but well, you can if you do this, but that looks horrible. Do D2, D3, 2D, 3D. All right, let's go with that. Maybe start with the basics of 3D. Yeah, exactly. Anyway, I'll not do this. I'll just copy this and make a version here. But anyway, let's start with the beginning. So I'll just go through here, try to see if there's anything. We probably don't need to do anything here. This is all probably going to be the same stuff happening here. Except for create camera. I mean, this should be like a 3D camera because this is a 2D camera. So already here, we need to make this into a 3D camera. Wait, I'm pretty sure. Oh yeah, game camera, right? Raylib camera, 3D. And now we have a few other things. So we have like position, target. So I guess position offset is like the same. We have up, which I guess we'll say is 0, 1, 0 maybe, or -1, I don't know. Why are you, oh yeah, equal, there we go. Oh, 1 second. Okay, let's see, FOV Y. Yeah, that's the field of view, I'm pretty sure. So I'm not sure exactly what this will be. Maybe it's a pi based, like radians. Let's do like, I don't know, 180 degrees for now. And then we have projection, which you can choose orthographic perspective. Perspective is, you know, the ordinary 3D, and orthographic is something else that I can't explain. It's essentially it's like changing the lens. If you imagine a camera lens, the lens that we have on our eyes is like a sphere, so it receives light from all directions, and that makes it look like how we normally see things. But if you have orthographics, kind of like having like a rectangle that only can receive light from straight ahead. Okay, I can't explain it better than that. You have to. It's easier if you see it. Anyway, there is actually a material in that makes light behave like that you can look through to kind of see in real life how that looks. That's kind of cool. Anyway, so set up Zig's templates file projects. I mean, this is my personal. my personal like template project. I've made like a script where I basically I've already made, this is from my pre-made project template that I made, and then I have a script that kind of copies over, like initializes a new project. It basically just copies over all the template files, and this is one of those files. So I have a bunch of files in my template project that I'm start off with. And for now, until now, I've only done 2D projects, so that's why this was camera 2D before. It was like, well, it was camera, but it's camera 2D before, and now I changed it to 3D. So this is all. This was my code before, and it's not a built-in zig or anything like that, if that's what you were asking. Okay, so that's our camera. I mean, I guess if we run this, how would this will probably crash because we're trying to get a camera that doesn't exist. Yeah. So I need to go to game, and there's a camera function, and actually you are now 3D. Oh yeah, we just changed that to 3D, so then actually we can change you back to game.camera now. There we go. But we don't have an offset. Oh yeah, this is like the HUD camera. Maybe the HUD camera. Oh yeah, now it doesn't make sense to have like the pixel size and stuff like that. Like zooming in, like that stuff does not really make sense anymore. I guess we could make a UI camera as well. We'll have like two cameras. One, we'll have like camera and UI camera. Camera UI, which is a 2D camera. Okay. And then here we'll actually add the camera UI as well. And this is rotation 0, zoom is zoom. Okay, so that still keeps, okay, we can still keep the 2D stuff in then, I guess. The UI camera, we can actually get camera UI. So we get camera UI here instead, and that should be good. Okay. Now that is actually generic. What's the best way to practice Raylib Zig? I think it's probably the way I'm doing it, like just make a bunch of smaller projects. I mean, I'm trying also to make like different, you know, different projects. Okay, let's disable the CRT shader here. Like different types of projects, and kind of bring a bunch of because what I'm doing is I'm trying to make like this project template that has a lot of like generic functionality that can be used potentially in any game, essentially, to kind of quick start me into making another project. Now you don't have to do things like that. You can just make it, you know, when you start out, you don't do that. You just make, you know, start out making your project from scratch. But after a couple of times, you kind of get, you know, at least me, I kind of get bored doing the same thing over and over. So that's when I start to kind of try to automate stuff like that. So that's what I'm doing. But I think if you do things like that, you kind of get a, you know, you get experience in how to apply different strategies, working with different things. Like I'm using like ECS which kind of works well for me with this ECS library that I really think is really nice for all kinds of things. It's actually, you know, you could use it. You don't have to even use it for games. You can use it as like a container to store things in and to grab things out. Like also like a dependency injection thing as well. But yeah, anyway, so I think that's probably the best way. Try to make something. Smaller projects. You make a small project. Maybe you try to make a medium-sized project. Make a bunch of. I think it's good to start small. Start small and then work your way up. Generally, I think that's good for any you know, like when you learn something new. And you know what I did like, you know, those classic arcane games because they are simple. They are 2D games, very simple games. You know, but they still have these, you know, nuances and rules and everything that makes it interesting to implement anyway. I think it's a good exercise to do. Even though you kind of think that, okay, well, if I can imagine it, maybe it feels like I've already done it, but that's not the case. Like there's a difference in imagining like a project and actually making the project. Because I went from like, well, I want to make an interesting project. Well, yeah, but you also need to kind of practice and learn how to do things as well. It's like, I'm pretty sure I can make it, but do I want to spend a bunch of time making this game when I really want to make another game, you know? But then it's like, well, it's not waste of time because you will, you know, practice and learn how to do things. Yeah, it's surprisingly hard. Okay, so let's see. We are over here. Let's excuse me. Let's make some. Let's make the camera kind of follow, I guess, the player. And I'm just gonna make the 3D simple 3D physics. So let me do like physics 3D. Okay. And I guess we'll keep this options here. Gravity, now you're a vector 3. And I'm actually gonna just initialize this with, what will this be? Like 0, negative something, 0. All right, the grid. I guess we could make a 3D grid system. Subidara, I think my way to practice is to try and create a system from one of your favorite games. Okay. Oh, so you mean like you take... Yeah, so you take like, so what you're saying, like, you know, you're not trying to make a full game or like the entire thing. You're just making like one part of one of the games you like that you think is interesting. Yeah, I guess that could be a way to get started. Yeah, if that works for you, hey, go for it. I guess, you know, that's a good way to get started, and then you can kind of work from there. You can because when you kind of it's a nice feeling when you get to tie the knot as well. Like you have one system, and then you make the other system. Maybe, you know, as I did with the JRPGs project. I don't know if you saw that. It was the last couple of streams. I made this JRPG game where there's like basically two different modes. There's the overworld mode where you kind of move around, the character moves around the world, and then there's the battle mode where you go into a battle, and that's an entirely different, you know, way of playing. And then, I mean, that's very similar to Undertale. You know, it's the same kind of thing. And so, but it was very satisfying when those two get connected so that you seamlessly you know, switched modes, and, you know, you went around getting to a battle. So what I'm saying is essentially, it's also satisfying to make like the whole kind of one slice. It doesn't have to be very deep, but making like one slice of the entire game, where essentially you just make the basic systems that enable you to do everything in the game, but not all the content, if that makes sense. System by system again can be created. Yeah. Yeah, exactly. But also what I'm saying is, you don't have to go like all the way. You can make like, you know, the simple as you can, but you still have like the basic building blocks in there, and then you make the next system as basic as you can. It doesn't have to have every feature, but it has like the basic stuff so that you can recognize that it's this thing where you move around, for example, or you go into battle, and, you know, you can do some things, but you don't have the whole thing in there. And then you connect those so that you can go from one to the other. So, and there you go. There's your basic thing, and now you just need to expand on those systems and go from there. And that's very satisfying when you have the whole thing, you know. And it's also like a little difference also, because it's like, yeah, you're making the systems, but you also have to make kind of the orchestration between the systems to make sure that you can move from one system to the other system and back and forth as well. So that's another piece that you maybe oftentimes don't think about as a new game programmer. I know that I didn't at first. One second here. All right. Looks like you got bored. No, I'm I was just, yeah, I just needed to respond to a thing here. Okay, so we got the 3D. Do we do like a 3D grid as well? I guess we could. I mean, this is actually already kind of generic, although this part... Oh yeah, actually, this would be nice. We can actually make this generic over 3D, because we can make these, like, do... Let's say the options include... This doesn't even make sense. This doesn't even have any references. I don't really know about this. We're gonna do... what is the vector type, essentially, that we're working with? Do we even use vector? Yes, we do. We do. So what is the vector type? V. All right, vector type V. V, and we could go for scalar V32. Look at this. Do you use HJKL for Newey? No, I use arrows. I'm a noob. Alright, let's make these V's instead. So now it's like dimensionless. We don't know what the dimension is, it doesn't matter. We can work with any dimension. And this is already dimensionless except for this part. But we can just do that. And then clamp the grid, you take V instead and return a V, and then all the scalars become generic, and V2 is not correct. Oh, well, okay, we need to change this. We need to change width and height. It needs to be size, and it needs to be the integer version. It doesn't need, I guess it doesn't actually need to be integer, but let's make it integer anyway. So this is an integer version of the vector. Okay, get cell. Now we need to do this instead. Now the problem here, how do we turn this into an index generically? That's gonna be something. It's probably gonna be possible, but I will, yeah, we'll figure it out. Hello, Godslayer. What's up? What's up? How's it going? Okay, now candidates also, like, instead of looping through each one, we will make an iterator. Or we could also, like, how would we even do the iterator is the question as well, because we're kind of moving. It's just moving the goalpost a little bit. So I think if we take if we do like type info v length, that gives us the, this gives us, well actually it's vector, this gives us the dimensions here. So we get d for dimension. So we can loop through the dimensions. The problem is we need to actually nest those loops. Eating snacks. Nice. What kind of snacks are you eating there? And the question is, how do we turn the nested loops now into a generic thing here? Because this corresponds to looping through one of the dimensions first, then looping through the, then nest that into the third one, and then nest that into the, the second one, and then nest that into the third one as well, if there is one. We could just do a switch on dimensions and say if it's 2, then we do 2 loops, nested loops. I'm gonna make this iterator for now, so it's gonna be easier to use here. So let's make an iterator. The iterator is gonna have a next function that will give you I guess a vector. It could also give you the actual. No, it doesn't give you a cell because we don't know thing. And this would be the candidates. Yeah. And then we need like some kind of index somehow. Starting at 0. Can be optional. We'll return like if self index is null, return null. Otherwise, in the end, we will increase you by 1, and so on. Iterator return equals self, which we don't have. Get it. All right. Now, how do we actually do this? So here we kind of move the goalpost over here, but in the function here, we can now instead make an iterator that we can get from here. And instead of doing all this, we will get the next from the iterator, which gives us the position of the cell, the grid position, and now we only have one thing there, and we can get, yeah, we put that in there because you need a position now instead, and then you take grid position times the cell size. Yeah. Okay. And then also now axis can have a Z as well. And the container should have Z coordinates as well. All right, penguin. Hello, penguin. All right. Okay. So the iterator. How should this work now? So we should be good with just one index, I feel. Or we could also have like one index per dimension. That's actually possible. Like you can make like an array of vector length. So you could make an array of indices equals to 0 times this. We could make this. You could also do this like dimensions equals type info v vector length. That's the number of dimensions. Okay. Hello, Avicena. What's up? Why do you choose? Wait, OOT. What is OOT? Why you choose Zig over C++? Because it's better. It's the best language. Well, why would you pick like an archaic language like C++? You have to get with the times. Come on now. Yes. So there we go. I mean, okay. My stance with language wars is like, I think they're silly. Like, I'm not trying to start a war or anything. I'm just joking around, you know. Use whatever language you feel comfortable with and whatever you want. Like, but I won't judge anyone using any language. I'm just saying, like, I've been self-taught in C++, but that was like 30 years ago. And I haven't kept up with the times when it comes to C++, because I know there have been a lot of changes since then. And but I did try to go back to it at some point, and then it just felt like kind of moving in a sludge, like moving forward really slow for me. So I don't know, everything felt bad when I tried to do some C++. So I don't know, and I tried Zig, and Zig is just, it's the opposite. It just, everything feels good, and that's why I use Zig. So there you go. There's my reason. Well, it's kind of like saying everything feels good, because you know. But that's the case with all programming languages. Like, you get stuck sometimes, but you have to solve it. But I would rather get stuck in Zig than in C++, probably. It's just my personal opinion, okay? As with all like programming things, essentially, I would say. So use your language that you feel like you want to use, and I'm just gonna say that Zig is a good alternative. If you want to try it, you can go ahead and try it, and you'll find out for yourself. So there you go. Okay, but how do we do this now? We could do a simple switch, like a comp-time cop-out thing, since we're only gonna have 2D and 3D anyway. I'm gonna cop out here. I'm gonna do like, if we have dimensions equals 2, then we're gonna do one algorithm actually, yeah, just return that. If we have 3, we're gonna return another algorithm. Okay. We can even, actually, I could even do this. I could do like next equals if n dimension, I don't think we need comp time here. N dimensions is 2. We're gonna do next 2D, else next 3D, because that's the only thing we have. Okay, so then next 2D is still this here. Okay, and then we have also next 3D as well. And next 2D is just going to be the same thing for index 0 to candidates max 0. We get x, and then index 1 candidates max 1, we get y. Actually, I think this needs to be +1 here. Yeah. Then we will say self index 1 or 1 plus equals 1. Here we increase. No, we do that after the loop. Yeah. Here we return. Well, we can just return like index. Actually, we can just return index, to be honest. Actually, this is just v here, but it's u size. So this essentially, this is just like to int v u size. But now it's a vector, so, but that's fine. Do you have a response for that, Avicenna? I'm gonna guess you're a C++ person. I mean, you don't have to have a response. But you kind of put me, you know, you kind of put me in a spot to kind of explain. So I did. So it would be interesting to see what your answer is. Or response, I mean. So we can essentially just return index, but we're gonna convert it. No, we just return index, yeah. But it's not null, so let's do that. Oh yeah. Actually, let's do this, because this is easier. Index equals this, or else return null. And then we can do this, because then we don't have to unwrap it. This one we do need to unwrap though, because we need to when we modify it, we need to unwrap it. Yeah. And if we're down here, then index equals to null, and we're done. And also here, we need to change index 1 back to, no, back to candidates min 1. When we're done with one entire in this dimension, we add one to this dimension, we reset that dimension, and also and in the entire beginning actually we need candidates, and we're gonna return candidates, and then index is actually gonna be I mean, this kind of depends then on... No, this would just be min, actually. To int. Yeah. We start out at min. Okay. And yeah, I guess we don't need these. Except here we changed index, but we copy it here. Right, this is a copy. So that should be fine. We don't actually need these here. Okay. I'm just trying, how could we generalize this over more? We don't need to generalize it, but it's just an interesting exercise. What you could do is you could have like a dimension, a current dimension. We don't really need to we don't really need to generalize it, but it's an interesting idea. I'm just gonna skip it for now. I just want to move forward. Okay, productivity. Come on, productivity. Yes. Okay, so for 3D, we simply basically have another nested loop here, which is index 2 now. And at the end, we do a similar thing. We say index 2 is now reset there. And in here, we will increase index 2. No, index is wrong, actually. This is wrong because we're... Yeah, that's just a starting point. So actually we do need these. But... Yeah, okay. I gave you a challenge, use Rust for one day. All right. Is there a, I mean, there's probably a raylib binding for Rust. There has to be. Or use some other library. But raylib is so simple though, and I've been using it for a while, so I'm pretty confident it is in it now. Okay, default grid. Yeah, so this kind of depends then on what we need to do, but I'm gonna just say that this is vector 3 now. Okay, and actually now we put size in here, which is an integer version of that. Size is size. We don't have these. And you. So this would be like times all of them. I guess we could do a reduce multiply on size. That should work. There is raylib bindings for Rust. Nice. All right. I might do a challenge of that. You have. I asked on Discord if anyone had any ideas or requests. I haven't gotten a response for now, but then again we don't have much people in there, so But yeah, that is one request that I could do. Yeah, sure. Rust. Going into Rust. See how hard it is. I would also like to do Haskell. We did the challenge. Terminal-based shoot-'em-up game in Haskell. A turn-based, I think it was turn-based shoot-'em-up in Haskell in the terminal. That was fun. So it would be nice. It would be cool to make like try to make like a 3D game in Haskell. Oh my god, yeah. Okay, so this one here, turning light. So now we need to be able to turn like a 3D or turn a position. This would be like get index, turn a position into an index. Actually, a size, yeah. So what this would be is kind of like, well, if it's 2D, we return position 0 plus position 1 times size 0. Okay. What if it's 3D? I guess this still holds, and this probably still holds. So this means, and then we times. I mean, is it just 2 times size 1? Alright, Penguin. Welcome back. Okay, Subidara. Welcome, welcome. Yeah, thank you for the request. Alright. Is this how it is? Let's think about this. You have, so this is pretty, I'm pretty used to this, so this makes a lot of sense to me, like, because so index is divided up in, so you have the X part, and then essentially it's divided up in lines, you could say. So the first line is on the first couple of, depending on the size, couple of width. And then each Y descends one line, essentially. So that makes sense to me. You kind of divide the thing up in lines. So now you're taking a 1D array and turning it into a 2D kind of structure. Now this, I guess, would turn it into a 3D structure. So this would still be one line, and then this would be a rectangle. And I guess this kind of turns it into a cube. I don't know. It kind of makes sense. Like, this is slices of a rectangle. This would be slices of both a rectangle and a cube, I guess. Oh, there we go. Thank you for the follow, XRA. You're the first person to trigger the alert. So congratulations. Because I've made it this far without actually having alerts. So there you go. Welcome, welcome. Thank you, thank you. All right. Cool, cool. Okay, so I'm just going to assume this is correct. Alex, sorry. Oh, nice. I was lurking on YouTube, but saw you on Twitch too. Okay, nice. Well, thank you for following. How to trigger it, is it from Twitch? Yes. So if you go on Twitch and you follow, or you can subscribe as well if you want. Prime is free, as they say. I usually don't talk about that, but yeah. Just to you can just do it to test it out. All right, if it works. But thank you. Okay, so yeah, this is actually, we need self here. Yeah, let's true self.size. I mean, this could, how would we generalize this though? I mean, I guess it would just be, we could loop through the dimensions. We could have index, and if, so index plus equals position D times size D minus 1, but if we're out of bounds, it needs to be 1. So what we could do is we could construct a new size that is size plus then it's got to be like n dimensions plus 1. No, it can still be n dimensions actually. It could still be n dimensions, but size 0, no, size D equal to self size D minus 1, and we'll go to 1 there, and then size 0 is 1. And now instead of doing this, we'll do size D instead. So the first of this new size is going to be 1, and then it's going to be, you know, the width and then the height. And then we return height. Okay, this is a generic one, I think. Cool. It will break if dimensions is 0, because this will be an infinite loop here, but I don't think we'll get that issue. Okay. So there we go. Now we can have get index there. Cool. So we basically made almost a dimension ambiguous grid thing here. The only thing that is not fully implemented generically for all dimensions is the iterator through all the things, which I'm pretty sure you can with using some trick, some like dimension variable and then changing this loop a little bit. But yeah, anyway, it works for our purposes right now, I think. Anyway, so right, the default grid now we need to change into a 3D. So this takes now a vector, and the grid, I'm just gonna say it's like yay large, and the grid is doing this. So I guess we can get like, get like a candidates. Yeah, let's actually just make this iterator function. It should be actually pretty simple, because we just have to construct a candidate. So candidates and this would be starting at 0, 0, and then, or yeah, actually, yeah, this would be scalar v0, and then this would be just self.size. So the entire thing. And then we just return iterator. So that would iterate through the whole grid. Oh, hang on. Rectangle. Oh, man. Okay. Okay. This needs to be a 3D now. Do we make this? I mean, it's a rectangle. It makes sense if we just made a cube version. You know what? Let's do this. Let's take this, make a cube, to Raylib. Do you have a cube? I don't know if you do. From Raylib. Yeah, we'll see. Check collision. That should be the same. Format is a cube. Alright. Now we'll make a hypercube, which I think is essentially, in maths, it's like, I think this is the case. It's like it can be any dimension, like a hypercube. I think normally, maybe sometimes you refer to a hypercube that's like a 4D cube or something. But I think that dimensions, probably this will be, yeah, so then we just return switch on dimensions. I don't think LSP will be able to handle this, but 2 will be, and then right, so now we can use hypercube to kind of select one of those. I'll go to game, rectangle, cube, and also hypercube. If we somehow want to generalize over that, which we could do, like for hitbox, for example. Hitbox could be a hypercube, but now hitbox needs to be generalized. Yeah. Oh wait, not hitbox. It's just gonna be this one, yeah. Hypercube. This one could be, actually this one could be generalized. There we go. Oh, whoops. Wait, you should just have next. No, it's position, grid position. Hello, Ian the Hunter. First, was there BSP already? Well, yeah, but it was the BSP was actually more like a 2D BSP with a 3D projection, I guess. Also, you made the JRPG. I mean, I made like a version. I can show you. Here's the JRPG. You can move around. You can go over to the water where you can't move. There should be battles. There's 5% chance of getting to a battle. Why am I not getting into a battle? Okay, this is not the authentic experience. Well, it might be, actually. The early Final Fantasy might have this experience, maybe. Or maybe I disabled encounters. I don't remember. How would you have CJK in that? Raylib has a font for this? Wait, CJK? What are you talking about? Why do I not get into a battle? Okay, but anyway, you can go into like a town location. Here's an NPC. You can talk to the NPC. And you can leave the town. And that's basically it. Not sure why I don't get into the battle here. There we go. Here's the battle. Oh my god, that was a long time without a battle. You're supposed to get it like every 20 steps, like on average. So here you can select your action, which is only one action. Yeah, it's like the old school Final Fantasy games. You could potentially have more than one character as well. So I've always been interested in making one of those games. JRPG is Japanese RPG. Yes, I believe so. So, for example, like Final Fantasy. Oh, so for example, you have Chinese, Japanese, Korean characters there. Well, okay, that's, you know, a JRPG just means it's like in the style of those like RPGs that came out of Japan. For example, Final Fantasy, Dragon Quest, Lufia. Essentially, it's like a turn-based RPG where you often like move around in like an overworld or in towns. And if you're in an area where there's enemies, you would get into random encounters. It doesn't have to be that way, but it's essentially JRPG usually means that style of RPG. It doesn't mean it has to be in Japanese. So I'm not like writing out Japanese letters. I'm aware, but that would be possible in Raylib. I mean, I guess, I think you, essentially how they do fonts is they just load in basically an image, and based on what you print out, it's just going to be like a section of that image. So you could have like your own font, or you load in a font and you type in the things. I'm not sure. I've never tried to do like, well, I think I did do Unicode at some point. Yeah, I think I have that in my other game. There's like a font somewhere. So, well, this is not really entirely the thing, because I think that Raylib does not have Unicode support in the source code. The source code does not have Unicode support. So the thing that I did do was this character, which I thought was maybe Unicode, but I think this may be ASCII extended or something. I don't know. But yeah. So what I did here is I just select out. Okay, I wanna, because maybe sometimes you don't want to load the entire font. The font may have all the Unicode, like all alphabets in the entire world stored in the font. And so maybe you just want to load some of those. So I basically just, these are the characters that I want to load in. And then you use that. But if you change the language, maybe you want to, you know, select all the Chinese characters, all the Japanese or whatever. But I'm not exactly sure how to actually do that. I think you just put maybe like in Unicode format here, but Raylib doesn't support that in source code. So you would have to escape it, I think, like you something, I don't know exactly how you would do it, but you would have to kind of escape it somehow. The font is bundled in the exe. Not necessarily. It's I'm loading in the font from a font file here. So if you use the standard Raylib font, I'm not sure where that comes from, but if then you can like just use your own fonts. You can just download a font and load it in with Raylib's load font function. No, that's not where I want to go. Okay, whatever. I forget where I was. Yeah, probably here. Okay. So this would be the grid position. I mean, we could get the index, I guess. No, because we could just get the cell. No, because we need to modify it. That's right. Get cell, but this could be a pointer as well. We could get the pointer here. Yeah. So let's just do get cell position, and the position is not correctly typed here because next. Why are you not like? Why do you not have the next? Is it just because of this? So I guess we could make this like, we could actually say that this is a function. It takes this type. Yeah, so there we go. Now it should know what this is. And we get this thing here. There we go. Yeah, that should actually be correct, yeah. Okay. Use of However, this is not correct because this is a USI. So actually we need to do game v. I need to make a new v function. Look at all these v's. I want to make a v function that takes any v type, turns it into t. Let's make this into this undefined. We'll loop through the length. We'll set u to convert components vd, and then return v. Alright. I mean, since this is vector, we could also do inline-4. Oh, shit. Oh, man. Okay, let's call it vec. Somewhat of a downside to have no Unicode, I think. Yeah, maybe. I mean, you can still. I mean, it's just that the source code cannot have Unicode. You can still like represent Unicode characters in the code. It's just that it doesn't, like in like strings and stuff. I mean, you can also have, let's say you have a text document, like a data document that actually has support for Unicode. You can still load that in and use that instead of trying to define it in code. So, like, for me, it doesn't really matter because I'm, you know, I guess if you're Chinese or Japanese, or I'm not sure how they usually name their functions or whatever when they program, if they actually use Chinese in the source code, that would be, you know, I don't know, a little bit, yeah, that would be bad for Zig, for sure. Because then they would be forced to use English or just, yeah, that would be it, essentially. Is Z command for Zig? Z? No, Z is a separate command. Z is like, it's like CD. It's like a smart CD, like change directory. So I can type like Z and do this. It will jump. Oh, I have to go out. I can jump to. It's essentially, it records your most common directories that you've been in. So if I want to jump to another place that I've been before, like JRPG, I can just type ZJRPG and it kind of knows where it is because it records all the directories that I've been in. So it holds that in there. So it's kind of like, yeah, it's just a smarter change directory. They don't use Chinese in the source code. Okay. Good to know. Well, there you go. It's a better CD, yes. I would recommend it strongly. It's a really nice command. Okay, so this is vec now. So this is like a generic vector construction thing. However, it's not actually necessary here because we know it's supposed to be 2D here though, so we don't actually need it to be. No, I want it because now I can use v2 though. I can, but let's do this for fun. So because these are usize and it's gonna turn into a floating version. So, and then this one is gonna be this here instead. Okay, there we go. Because vec is like it uses convert component, which basically takes almost anything. It can be an integer, another type of float, whatever, and it turns into a F32, which is the target type that we're using. So it's a very convenient thing, indeed. All right, now to construct this grid, I'm gonna use, well, we can actually just grab it out like this. Wait, this is the iterator. Yeah, Z is unused. So Y equals height -2 x. Yeah, so this would create kind of like an infinite plane. I mean, it's not infinite because it has oh yeah, this would be size 1, size 0. Oh. From int. What is the third called? All right, cool. We have a couple of other issues. Next 3D found, blah, blah, blah. Oh, right. These need to be 2 ints. There we go. So what's the thing you're going for here? I'm just trying to make my first 3D project, and essentially I've already made like a project template that kind of works with 2D. So I'm essentially converting some stuff to make it like generic over dimensions, so that I can use it in both 3D and 2D here. How do you add a zig LSP in NeoVim? Okay, well, which version of NeoVim are you using? Are you using? I'm using like an older version, version 10. So my setup might be different from yours, but you can essentially, you can just go into, let me find this here, LSP config NeoVim, and there is, yeah, go into this page, and there you can see basically how to add any LSP that is, I guess, currently kind of registered here, which is a lot of different LSPs. And ZLS is somewhere down the list here. But a note here is that this is for the latest version of NeoVim. So I think it's like 11, version 11. Is that the current version? Oh, 12. So I'm not sure if this is for 11 or 12. I'm using version 10, so I'm way down. I'm way off with my version. I need to do an upgrade at some point. It's just, I can't, I just, yeah, I don't really have a good reason to do it right now, though. So, but anyway. Just 1 second here. All right. So, what else is the issue here? We got something here. Cannot assign to a constant. Okay. Vector index not comp time known. What? Oh, the index is not comp time known. We could do an inline 4. Then it would be comp time known. Incompatible types F32 and usize. Right. So we can turn position into a usize, or we can say that people have to put in an usize index. That's probably better. Probably. Because you're not supposed to put in like a world position here. It's yeah. And also then you I should probably make that into a thing. Grid position is 2int usize b, and I will search for this and replace you with grid position, or grid, I guess could do a grid coordinate. All right. And you are grid coordinates, and you are grid coordinates. There we go. But now these are F32, so now we can actually just do this because they are usize. There we go. All right. Now this is an issue because these are not floats. So we're gonna do an F grid position is well, it's gonna be in a vec3. Well, actually it's from int. And actually we can just do this immediately here. Okay. Let's handle all possibilities. I'm gonna do unreachable. We're not gonna have any other dimensional things. Expected this, found that. Do you really expect this, found that? Yes, you do. I mean, we could just do to or from int. Okay, size, we already have size. But now this needs to be from int. Right, this is a hitbox, which doesn't actually make sense at all. We just need to get the body oh yeah, that was a function that was nice to have actually. You know what? This could probably be like a hypercube, depending on, but the body is not. It's not. I mean, we could make a game vector. We could make like vector. We could make like base vector, or I don't know, world vector maybe. So that would determine which vector, like which dimensions are we using. So we could actually just use these here now. And to change from 3D to 2D, just change that to that. Oh yeah, we got this as well. No, this is vector 2, this is vector 3. No, wait, this is vector 3, right, as well. Oops. Oh, yeah, okay, well, I guess we have to do a thing here. Switch on dimensions. Yeah, let's just do n dimensions. Comp time 2. We return x. Yeah, actually, let's just do an if comp time dimensions is 2. We'll just do this. Otherwise, we'll get z as well and return x, y, z. Hey, okay. Basically the same thing, except we changed the thing here. Acceleration. And we don't have those either, so we have to make them. And rotation, rotation is also gonna be interesting. I guess we don't care about rotation for now. I just want to make this work in a very simple way. I mean, rotation is very important, though. Maybe, we'll figure it out. I'm just gonna make this super simple for now. And we'll do the same thing over here. All right. Right, min x doesn't exist. This is just going to be min, and then max is max. Hitbox, hitbox, hitbox. This is... So we don't have hitbox, we have body rectangle. And now actually this could be a hypercube and dimensions. Here we go. Alright, now grid position here is a U size, so we have to make it into a float. But it's only used here, so what we can do is we just say grid v from int. No, not grid v. Game v. Thank you, Piano. I don't think so, Subedara. It's just a test project. But yeah, I appreciate the optimism. Why is the switch better than if else? So yeah. So switch allows you, well, in Zig at least, switch allows to do something like called like exhaustive checks, which essentially says that, let's say you have an enum. So you have an enum called animal or whatever, animal type is a cat or a dog or a turtle. Okay. And then let's say you have a function that's like is animal a land walker or whatever, takes an animal type and returns a bool. Okay, so if you would do, you could do if animal equals cat, return true. If animal equals, here we don't need to do else if because we're returning as well, but whatever. Is true. If it's a turtle, it's false. I mean, okay, a land walker. A turtle can walk on land, but I mean mainly, you know what I mean. Anyway, it doesn't matter. What matters is the programming part here. So, so there you go. You do this. However, what if later someone were to enter, okay, well, now we have rabbits as well. Okay, now this function will have maybe, it needs to return something. If neither of these return, like if any of these doesn't go in here, then you would need a fallback. So I guess a fallback would be, I guess, false, because we don't really know. It's gonna be, you know, unknown, essentially. You could also have like an option on here where you return like null if we don't know if it's a landwalker or not, or something like that. But now we have another case, which is rabbit. So you would have to kind of know that this function doesn't tell you that, hey, now you have a new, you need to cover this new thing. So if you call this function with a rabbit, it's gonna fall through because it's not checking the rabbit case. So it's gonna fall through to null. Now you might test and figure this out, you know, in the long run, but imagine you have a larger code base and it's gonna be, you don't remember that you have this function. And there's going to be some weird error later on, where it's like you can't really figure out what's the issue is. So what you can do then is you can say, instead of doing if blah blah blah, let's say this is the if version. Okay, let's make the switch version. So now you say like switch on the animal, and now you have, so cat is gonna be, we can also do a return here immediately so we don't have to type return every time. So a cat is true, a dog is true, a turtle is false. Okay, And we don't have, well, we can have a fall through. You can actually add a fall through case, but I wouldn't actually recommend it. What happens if you don't have a fall through case? So at this point, there's no issue here. But if you let's remove the fall through case, and we remove the rabbit. Okay, all cases are covered. So that means that you don't have any other options. So you don't need a fall through case. But so that this will compile all fine. But if you add a rabbit, now this will be a compile error. Why? Because Zig forces you to cover all cases if you don't have a fall through case. So now you get a compiler, and you get the compiler's exact, so you can use the compiler to find exactly where to add the new cases. I can't really show you the compiler now because this is not actually compiled. Well, I guess we could call the, I have to call the function here. Let's do a rabbit, for example. So now we should get this error here. Switch must handle all possibilities. If I remove rabbit, then we don't get the error. Okay, but if I add rabbit, now we actually get an error here. So you would know exactly where to put the thing. So it's a really nice way to kind of make sure that you're covering all the cases. Okay, and then you could do that, and then you won't get the weird error maybe later on. So that's one reason why switch, at least in Zig, is sometimes preferable to an if as well. And I will admit, like, I usually go for if first because switch just feels more, it's just involved more, like, to get the started, right? If is easier to get started, like if this case is true, do this, if else, as if this case is true. A switch is more like it feels more, it takes longer to get started maybe, but it's useful in these cases where you have an enum you wanna look at, or you wanna match against specific values. Then a switch is really good. Anedonia. I've never used switches as much as I have until I started using. Same here. But to be fair, like switches in Zig do have more utility than in a lot of other languages. So just because of the exhaustive thing is basically what makes it good. Expected rectangle found cube. All right, so that U need to be a hypercube with dimensions and dimensions. There we go. Same thing here. And then the axis actually also should have a Z. Okay. And you need to be a vector type V. Okay. Okay, this should be world vector. We have a lot of places to change, I think. Right, so now it's like, okay, I guess 0 for Z. The renderable, yeah, we need to make like renderables. I guess we need to make like cubes. I'm not sure, what does Zig do if we render a rectangle in a 3D projection? I don't know. And now you need... What is this? This is the thing, right. Actually, I'll just remove you because I don't want you. There we go. Okay, now we're in draw. So this will be world vector now. Yeah. And rotation, I guess it needs to be like a quaternion or something. I don't know. Yeah. See, this doesn't make sense now. A rectangle, we still should be able to draw a rectangle. I probably need to change, like make a version of renderable, like a 2D. This is the 2D renderable, and then we have a 3D renderable. Yeah. .3D. And I'll just start out with a cube. And this is vector 3. I'm gonna remove rotation for now, because I don't really know what that will be. I think a quaternion is a 4D number. In its cube. Color. Yeah, sure. Here's the cube. Size. All right, so cube, draw, I guess, well, we're gonna do demo. So this would be renderable 3D. All right. Okay, and now let's change you to 3D. There we go. Draw grid. Right, so now this is 3D instead. And we'll get, instead of this, we'll get the iterator. We'll get the grid position. In there, the size, the position is gonna be from int, and this is gonna be draw cube now. Yeah. Wait, grid. There we go. Okay. Position, right. So now this part, vector is a world vector. There we go. And here we can actually use scalar instead. It's gonna do the same thing. Length mismatch. Offset. Right, this is world vector now. Okay, so this part is not I guess from dimensions. We can have n dimensions. It's actually, well, it doesn't need to be comp time. It could be comp time, but we know it's comp time though. But so if n dimension is 2, it's gonna be xy. If it's 3, it's gonna be xyz. And you also have z now. Okay. Right. We need these. Oops. Well. Okay. Expected, blah blah blah, found blah blah blah. Position, right. Okay, now we can do from dimensions and dimensions. We should really have a game and dimensions probably. Yeah. And I mean, I guess the hypercube, we could also say like the hypercube, we could actually just say it's going to be n dimensions, so we don't have to supply that every time. But the problem there is that now we can't actually use it as a generic hypercube from this place though. But whatever. So now we don't need to supply that, which is, I guess, a little bit better. There we go. And else unreachable. Gravity is vector 2. It's actually a world vector, and the preset. No, because this is physics 2D, that's right. Which we shouldn't even use now. So actually, systems physics is now physics 3D. Oh. Okay, there we go. Oh yeah, and then this is, well, we can just do this actually. And yeah, now is maybe the time at some point to actually just make these be in an array instead. Because that would really reduce the amount of code here. There's a lot of duplication here, but yeah. Alright, let's see, renderable. Let's change this out to this. Right, draw cube V position. Wait. Oh, cube. Yeah, they don't have a cube construct. I see. Yeah, so it's just going to be position and then size. Okay. That was all the compiler errors. Now, a lot of things have changed into 3D. Wait, you can see the physics kind of working here. We're falling down. Yeah. So let's go back to demo, because I think the player is created at some bad position. Let's do like up 10. Oh, we're still falling. I mean, maybe we're falling too quickly. I'll change this to maybe 100 instead. Okay. Let's see, grid or create grid. So where is this grid? This is at So the grid is like, it's like a cube of space where the bottom is supposed to be filled in sort of with. So I think if y is there, I don't actually care about x. I'm just gonna set the bottom to true here. We can even set -1 here. Yeah, sure. Wait, y is equals width. What the hell? That's not correct. Height. Well, it's gonna be the same anyway, I guess. But right should be right, as we say here in the north. Okay, well, there could be a lot of issues. There could be some issues. I'm gonna disable gravity for now. Perhaps. Did I have a gravity factor? I do. So we can go to our player and I can set maybe I don't have this as a thing here, as a target actually. Yeah, let's do gravity factor. And we can even target any kind of dimension on it, I guess. Gravity factor. It's gonna be that. It's gonna be player element. And I guess we can also, yeah, we'll leave this dimension type. There we go. And we need to actually set to 0. Actually, why is this? This is not a scalar. This is a this here. All right. And now we need to be able to supply the gravity factor. So let's do that. I could probably generalize this. Wait, gravity factor is a single. Oh, so it's okay. Right. So it's just gonna be this. Yeah. Okay. Then I was wrong. This is just a thing, and you are just 32. You are not a thing. It's got a gravity factor set to 0. Right, so now gravity doesn't affect us. And what I want to do is also make it so that we can look around with the mouse. So I'm gonna go to basically controllable. We need kind of a new thing here, so I'm gonna copy you, make I guess FPS or something, And we're gonna figure this out, but let's take this one, make FPS here. Oops. And also input. All right. And then we'll go to, I guess, preset. We could actually add this here, perhaps. FPS. And this would now be, yeah, this would like be this. And now actually we kind of have to change the physics here as well. But I won't do that right now because we already set it up, so it should work properly here. But we can change U to FPS, 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 and we'll get this one here. Right. I mean, I don't know, and drag. Sure. Okay. Oh, I forgot to change this as well. I'll not do anything with this for now. We'll figure this out at some point, but I want to make it so that we can move around essentially. Yeah, because this also, yeah, body, we don't care. We want to get like, we actually want to get like the camera, I guess. Okay. All right, so we get the mouse position, or wait, is it like mouse? I mean, we could go into Raylib example to see how they do it. I'm guessing it's like mouse delta. You get mouse delta and you do things there. But I'm going to go to, why is this not showing up? There we go. Raylib examples. And should be some kind of 3D somewhere. Here. 3D camera free. Camera mode. Alright, let's take this one. And you can see you can get the kind of mouse locked in here. So let's see how they did it here. We just scroll down. Can I put, why is this red thing here? Okay. Yeah, so position. Yeah, okay, so the position is like the position of the camera in the 3D world. Target is like where you point it. Up is the up vector, rotation towards target. Okay. I think I had the same. If maybe I put negative here, I'm not sure. FOV is, oh, I see. So this is in degrees. I put it in radians, so we have like 3. Wait, did I times it by 2? So we have like tau number of degrees. 6 degrees. 6.3 degrees. Perspective, right. Okay, let's start with changing the camera to kind of match this here. So camera, no, it's in setup. Okay, that was correct. The position should actually follow the. So FOV is bad, so I'm gonna put that to 45 to match the thing. And we also go to camera system, and if we follow the player, I'm just gonna change this to one thing. And this is now position instead. We can even do camera position equals 2×raylib. And I'm gonna do position minus pixel size over 2. Wait, is that really true? No, it's just gonna be position. The other is like at the 2D projection. So it's just a position of the player. Alright. Oops. So there we go. There's the camera thing. Now, disable cursor, limit cursor to relative movement inside window. Okay, we could do that as well. Disable cursor. That should happen in disable cursor. All right. Now we have the update camera function. I guess that's where we need to look. Where is that function? Not sure. Oh, I see. It's like a built-in. Oh. Okay. I mean, sure. Okay. Wait, does it include translation? Like, I would like to make this on my own, like not use a built-in, but I guess we can try it. Camera, is there an update here? Yes, free. Oh, there's even first person as well. Okay, let's try first person. See, Raylib has like, for 3D, Raylib has a lot of built-in stuff. It seems, both for like shaders and things like that. Okay, well, let's just not do anything in here for now. And I'm trying to look in some direction. I don't see the cube. Let's go to draw. Are we calling draw grid? Yes, we are. Let's just draw a cube in front of us, I guess. Draw a cube. Position is... So we are at 0, 10, 0. Let's draw it at 0, 10, 10. Size is 5 by 5 by 5. Color is white. Will that show up? What? Oh. Right, these are Raylib vectors. Right, I forgot. Why didn't that show up on LSP? Who knows? Interesting. Should this be negative? I mean, I guess it depends on which way we're rotating. I'll try to look around, I don't see anything. Maybe it's too far away. Now we should be inside the cube. Which... Okay. Well, let's draw one in front and behind. No, wait, that's wrong. Should be like 1, 5. There we go. Okay. Not sure what's going on. I mean, draw UI still works. Oh yeah, wait. Oh yeah. Yeah, because then we also draw the texture on top. But that should be, that's not, yeah. Because the 3D drawing is drawing onto the texture. And then we're drawing the texture onto the screen. That should still work, right? That should still be good, right? Or should we try to not do that? I guess. Then we can't really use shaders though, like full screen shaders. But I guess we'll try this. If this doesn't work, then it's something else. Okay. Okay, it's something else probably. So, okay. Let's go back to see what else it could be. So we're at 10, 10, 10. It's the position. All right. The target is 0. We also have target 0. It's just looking at the origin, I guess. We have update camera. Press Z and we point to the origin. We begin drawing. Clear the background. Begin the camera mode. That should already be happening. I'm gonna double check that because we are calling the bindings camera begin, which should, yeah, begin 3D mode. Yeah. So that's just a convenience thing there. And we're drawing something at 2, 2, 2. Oh yeah, actually, since we're looking at the origin, we could draw this further down then. So if this is at the origin, we just create one at the origin. And make it, how large is this one? It's 2, 2, 2, okay. Yeah, so we're kind of dealing with the same sizes here. We should be looking straight at it now, because the target is 0. Still doesn't show up. Okay. Okay, what else could we do? Draw grid? I don't know what that means. Oh, that's the 3D grid. Okay, we can do that. That's a built-in, I guess. Sure, let's draw the grid. Slices. Spacing. We should see it. We should see something. We don't see anything. Listen. Okay. Create player. We are at 0, 10, 0. So we should be like straight up from the cube. Let's also do like 10 to 10, like in the thing. Okay. All right. Position should be set to the body position, so it should be moved up to 10, 10, 10. Okay. And then we have the UI here. We changed the FOV. This is perspective. Okay, yeah. Interesting. Whoops. Why is this like this? Why are you like this? Let's just skip everything else. This is the only thing we're doing. It's just black. It's just blackness. Let's also skip this part as well, just to make sure there's nothing else ruining everything. Still nothing. Okay. And this is the 3D, yeah. The 3D camera. I'm pretty sure this worked at some point. That when we did the BSP stuff, we did the same kind of thing, but what the hell is going on? Let's say we don't actually do updates, and I'm gonna change the camera to start at the same place. Okay, so what the hell is happening? Can I move around? No. Oh, because we're not updating. Well, so, okay. So something in here is making it not work properly. Is it this part? Wait, follow should be true. Okay. That should be true. Is that it? Is that it? I guess. A WASD like rotates. That's strange. And this one strafes. Keyboard strafes. Okay, but there we go. We have a basic thing. I would like to, you know, not use the built-in FPS controls, which does not make sense to me. And make my own though. So there we go. Let's backtrack a little bit here actually, because I want. All right, now we're back into the original like texture mode. I'm gonna put you back here. See if we get the same cube and stuff. Okay, cool. Right, so it did work with the texture mode and stuff like that, so great. All right, we still don't see the grid though. That is kind of strange. Still don't see a grid. that we should. This one is called, right? Yeah. Okay, well. Yeah, that was what is strange here. I'm gonna check like set to solid. No. Just checking. Okay. Grid init. Maybe the iterator is broken, it doesn't work. Okay, it initialized the first one. Q. So there's something wrong with this. And then let's say, okay, grid candidates. Well, we could do it here. I'm just gonna say any iterator candidates. Because it should be like 16, I think 16 is the max. No, it's 0, okay. Well, it works in that case if it's like, if that's true, but it's like we should, I'm trying to use size here. Size is 16 by 16 by 16. So why the hell did you become that? I'm not sure. This is probably, yeah, this should be work. Min is min, max is max. Is it the copy that's the issue? Because they are vectors. Like if we just put min here. Max instead. Is that gonna work? Oops. Oh. Oh my god. Okay. Yeah, that was also a blunder here. I should use the init function. I never used that. Wait, expected float. Where was that called? Grid 72. Oh, because candidates is already a use size. There we go. Still says max 0. Yeah, something is wrong with like copying this. So I'm gonna do this to try and see if that is the issue, like getting the pointer to it instead. So I'm gonna make this a var. Doesn't seem to do anything. Okay, let's backtrack that. So we seem to get 0 in here. Cube size. This doesn't even exist, so that's, yeah. Get collision. Yeah, so this is like check collision cubes. Boxes. Okay, it's a box. Oh, it's called box. But there is no box. There's a bounding box. Bounding box, okay. Min-max. Oh. Okay. And then it should be just a bit cast, but maybe not, we'll see. And then the box. Does not have check collision, but we do have check collision boxes. Box 1, box 2. Get collision box. That doesn't exist. I guess I don't use it anyway, so I'll just remove it. Okay. Anyway. I was just looking if this was initialized badly. So look at this, like initializing candidates with hitbox 10-10-0, size 16-16-0, min max 0-0-0-0-0-0-0. So that seems bad. Also, there's clamp to grid as well, but the size should be correct. Yeah, size is 16-16. So the clamping. So now what is result min max? Just to make sure there's no like weird data thing. Okay, so the result actually is correct. The cell size might be wrong, though. Oh, because the hitbox size. Wait. Oh yeah. Oh my god. Okay. So actually, where's the iterator? Okay, so this is wrong. The size here is like in cell coordinates or in grid coordinates. It needs to be in like world coordinates. However, I think I should change that now because, well, let's do like two versions maybe. Like this is supposed to be world coordinates. And then we'll do init from grid coords. So we'll do like position or offset. We can even do min max. Or let's see, offset and size maybe. Yeah. Okay, then we don't need cell size. We're not gonna divide by cell size. We're just clamping. And these are already grid coordinates. So we really need like a clamp for ints. And you are already no, so this would just be self size. And ooh, it would be nice to have a scalar version of anything actually. Yeah. Okay, that should work. And then min size minus v. Yes, and this gives us a grid coordinate. Okay, now the min is offset, and the max size minus 1. Oops. And then we don't need to int, we can just use the int version. All right. And now we go to iterator down here, and we'll do from grid coordinates instead. But now we provide the scalar here instead. Record 0. Actually, we could just do splat 0 here if we want, because yeah, that also works. And then just self size. All right. Oh, get some error. Grid 6 times. Vector of floats, float type found, reuses. So you are a grid chord, round. Oh, it's because of the round. Okay, I guess we don't need round since it's an integer. Okay. Okay. Okay, here we go. Min 0, max 15. That looks correct. And we initialize a bunch of these. But it only goes through one of the things, and then it's done. So there's something else wrong than with the iterator here. It just goes through one of the slices on Z, and then it's done. Okay. Interesting. Zero, zero, 1, 1, 2, 2. 2 plus equal to 1. We return. Next time we call, this should be updated. So now we're at the next one, and so on until we go down here, where we loop through again. 2 is at the min 2. 1 is increased by 1. That should go through everything again, the next slice, but it doesn't for some reason. And index is set to min. So it starts out as 0, 0, 0. And then max was 15, 15, 15. Yeah, we iterate. So I'm not sure why it ends there. It falls through here. This should +1. And then should just go back and go through again. Because this is reset to min. So it should go back to 0. Oh, we could... Wait, no... But this shouldn't be indexed, though. We should actually... Yeah, we should actually use this, because otherwise it won't update. I'm not sure why. That feels like that should be an infinite loop, almost. Why is that not an infinite loop? Because we're adding 1, but this isn't changed. Hey, yo, Pierito. Did you reach some sort of milestone here? "45 stream streak." Thank you very much. Look at this infinite. Cool, cool, cool. Welcome back. All right. Okay, will it work now? Probably not. Oh wait, it does work. Okay, so there you go. I'm not sure why it... And there we go, it's setting things to solid. Cool. Let's remove these locks. So it's setting things to solid. So we should see, it should be somewhere. Let's go back to draw. Let's draw the... Let's do like draw grid so we can see it. So we have some notion of looking at something somewhere, so we can kind of tell. Oh, there we go. Whoa. Wow, this is... Oh, it's actually rotating as well. How do you move? What is happening with the camera? I'm not sure what's happening. I'm pressing W. I have no idea what's happening. Okay. That's not the grid that I thought we were making. Interesting. Okay. So if Y height very strange. Very nice. Yeah. Welcome, Vincent. What's up? What's up? Trying to make my first 3D kind of project. It's not going super fast. Man, we've been at, what, 4? I mean, okay, so I've done a lot of things, though. I've basically converted the physics system, the bodies, like all of the things that we previously had in the temple project to work in like both 2D and 3D now. So I've done a lot of work for that. I'm just trying to figure out, okay, now I'm just trying to make like a grid. So I have the spatial grid system. This could potentially be used in like a Minecraft game, maybe. So like a mini Minecraft. I'm trying to build like a bunch of blocks, and it doesn't seem to be the correct, like, why is it a stair? Why is it stairs here? Also, let's fix this camera thing. So, where's that camera system? Instead of just calling this, actually, yeah, instead of calling this, let's do that. And then I'm gonna go to, well, I guess we can just do it here. Let's get mouse delta maybe. Mouse delta and camera target. How the hell do you do this? It's like a yaw and pitch. Oh yeah, I believe I looked it up at some point. Actually, we already have a project for this. I should just look up the BSP. We have like BSP somewhere. Yeah. BSP camera. Look at all this. Look at all this crap happening in here. All right, we got mouse delta. Pitch your, oh yeah, we need to kind of store this shit as well. Sure, let's just do that. Speed. Oh yeah, the mouse speed, right. What did we set that to? Yours 180, okay, why not? Direction. What's the speed? Oh, just the thing. I mean, it should probably be something you can like set. Speed. All right, I think that's good. 95. That sounds more like it. 45 is like, what the hell is that? Demo. No. Setup. 45. 95. Is that actual, like the usual FOV setting? Because I usually go for something like that. That looks good. Okay, there we go. Now we can move around the camera. We're using our own kind of system for that now. So I want like WASD to move us around. Let's go to controllable FPS. So move up is actually move forward, I guess. and move down is move back, or backwards, or backward. Okay. Why is that not? Oh, there we go. Body. Okay, well, hang on 1 second. Acceleration, let's do, so here actually we have like apply acceleration X, add control speed. Look at this fancy programming. And this is Y, and this is plus. Okay. Now, why are you telling me this? Wait, raylib 5? What the hell? Oh, it's because I'm looking at another project. I think that used an earlier version, perhaps. Stop it. All right. So acceleration X, Y. Actually, they should not be Y. They should be Z. Well, actually, no. It shouldn't be any of those. Actually, well, I guess we'll start here. We can, because it's supposed to be like the direction based on something. Am I moving at all? Speed 200. Okay, that should be good enough, I think. And then the camera is actually following this. Yes, do we change position? Otherwise, whoops. No. But we do have the direction. The direction is like the direction of, I guess, that's the direction you're looking at. In some type of convert spherical to Cartesian and directly assign to. Okay, direction is just the a small offset in the direction that you're looking at. Okay. So that's the direction that you should move. Like if we were in free mode, we could take this and add it. Instead of doing this. So let's do like, instead of this, we're gonna do position, X, Y, Z, and we're gonna add camera direction. except it's gonna be rotated. Okay, well, forward, back should be like negative. That, yeah. Left and right should be rotated, but oh yeah, from raylib. Wait, why is this a ray? This should be our vector. But yeah, that doesn't do anything. Not sure why. Are we calling this update? Yeah. Camera, yeah. We're also showing that coordinates of the body is not changing. Are we getting in here? Hello? No, it's not even going in there. Okay. That might be the issue. Is down, move right. Why the hell is that happening? Do we not have any controllables? Is it not enabled? It is enabled. And it should be it should be on the player, yes. If we do this, we should be moving though. Okay. I guess we're moving kind of slow, maybe. I'm not sure. But that's not the issue, because we know that it's not the speed that is. It's we know that we didn't go in there, so yes. Are we here even? No? What the hell? I'm pretty sure this is called. Yeah. Wait, no, this was not disabled. Okay, I thought that I forgot to update this, but that doesn't make sense because we already... We should have this. What? It doesn't even go in there. What the hell? Oh. Oh my god. Because we have rendered. Oh my god. Okay, we don't even need a renderable, to be honest. Like, yeah, because I changed the renderable 3D. Also, the player shouldn't even be renderable because the player is not even shown right now. So, because it's an FPS. Okay, now we get some weird error for some reason. Index out of bounds. What? Oh, wait. I know what the issue is. I forgot to initialize some of these new things. Yeah. Yep. The problem though is this might not actually be 3D, so let me move you guys to your own little space and then check if from time and dimensions is 3, then do this. I think that's it. Position, velocity, acceleration, size. Yeah. Okay, was there anything else? Gravity. Should be fine, yeah. Actually, it's not fine. Oh, spelling mistake. Velocity 1 or 2. That is good. Yep. Intersection iterator. Oh, right, intersections. Rectangle, yeah, okay. I have to maybe do something there for 3D. Alright. Or just skip that part. Hey. And you can see it kind of glides a little bit as well because of the... But yeah, cool. We got this part working kind of now. Okay, so why are you like this? Also, the collision system is kind of trying its best here. What the hell? Okay, so I guess the background is still drawn as a kind of billboard. But it's only shown through here. Okay. We found the secret, guys. Secret background. Okay. Great. Should I even bother with my own like collision system for this? I don't think so. I think I should just go for like box 3D or something. Should we just do it right now, actually? I don't know. It would be kind of fun to... Well, I mean, even if you use, like, let's say Box 3D, how hard would it be to make some kind of what's it called? Minecraft thing with that? Not sure, but I wanna figure this out. Why the hell are you a staircase? Or are you just like rendered as a staircase or something? Oh, wait. Oh, but no, that should be like all the 14 Ys. Yeah, because up and down is Y, right? Maybe something is wrong with draw grid. Is it that the case? Like, if Y doesn't change, it should not be a staircase. It should be a plane. It feels like such a stupid problem to have. I just hate getting stuck on these stupid problems. I'm gonna look if there's any more coffee. I'll be right back. Alright, there was no coffee, so I had to go into the rainforest, pick a bunch of coffee beans. I had to put them to dry in about a month, and then grind them up and boil a bunch of water and carefully pour it in. So yeah, there we go. Now we've got some. Alright. Wait, so that means that the grid is correct. But also not. I'm also gonna change the grid, the size, because it's way too large. I'm just gonna change it to 1. Okay. Still, why is it a fucking staircase? What the fuck? Okay. Is there something wrong with this? I mean, there might be something wrong here. Wait. Draw. Yeah, is this really how we do it? Or do we actually need to times it again? Yeah, I think that makes more sense. I think we're overriding something else. Yeah. Okay, let's just do this. If dimensions is 2, return position 0 plus position 1 times size 0. Otherwise, if dimensions is 3. I think here, for the third one, we return 2 times size 0 times size 1, I think. Because we need to jump width times height to get to the next one. Yeah, that makes sense. It's essentially the number of elements here times the number of elements here. Like x, y. And this one is like the number of elements in the previous list. We could still make it generic, but I'm not gonna bother right now. And if we're down here, it's unreachable. Okay. There we go. And I mean, it looks like the... Well, maybe it doesn't work actually. Yeah. It feels kind of strange. It doesn't work exactly here. I wonder why, because it has kind of the same... like algorithm as in 2D. Oh, actually, the player size is like way too large. Yeah, let's just make it like 1, 1, 1. And we don't even have a renderable. Okay. And we're moving a little bit too quick. So let's change that. Still moving kind of quick. Huh. Yeah, why are we moving so quick? Oh yeah, because we're okay, I know. Controllable system. Yeah, because we're just adding the direction. So we could you know what? I'm just gonna call you apply. So this is strafe. I'm not gonna bother with the strafe for now. We'll just do forward and back. And so what we want to do is like normalize this and then times it by controllable speed. And also times the delta time. Or time step. We don't have time step. Well, it's going to be the delta time. No. Yes, because we're changing the position directly. I mean, we could also change, we could just change, I guess, set the acceleration to that. However, here we're gonna do negative speed. Hello, cool guy. 3D game. It's just yeah. Well, it's I do have. I'm trying to make FPS controls. Or rather, I mean, this is kind of like free space, free camera movement controls. Okay, why? It's like the collision is like in another place than it should be. Also, I can't move this way for some reason. Yeah, one of the axes is locked. So it's only X and Y. I think Z is locked, perhaps. You are Vector 3. Doesn't make sense that it would be locked. Yeah, so basically, I'm just trying to do basic things in 3D. I'm not trying to do like an actual game. I'm just trying to kind of learn the ropes. Just make it work. We got Freddy, you said you won't be coming for the next 3 days. I didn't say that. When did I say that? I probably won't coming tomorrow though. Next week, I will be off. I think it's Tuesday to Thursday, I believe. I said that yesterday? Okay, well, either I was delirious or you heard me wrong. Probably the first one. But I guess what I meant to say was next week I'm off 3 days. From Tuesday to Thursday. This week I'm off probably tomorrow. I won't be streaming. And on the weekend, we'll see. We'll see. Usually it won't. Maybe some evening streams. We'll see. All right. No, I'm not stopping the stream, Penguin. I was just answering a question. I will be going for a little bit more. Maybe like an hour. An hour more. Of the stream gonna raid, yeah. I will try to remember it. Thank you for reminding me. I should always raid at the end of the stream. Sometimes it just feels so, I don't know, it feels weird sometimes to raid and run. You know, just raiding and just leaving immediately, but yeah. I guess it's also the point of sending people off somewhere. Because that's what I usually do. I just raid and run, you know. We normalize the thing. Wait, are you calling the correct normalize? I think you do. Because we call 2'raylib. And you are a vector 3, so that should be vector 3 normalize and not vector 2 normalize. And then we scale that up. That's just splat. Unless we forgot to do that here, perhaps. This should all be correct. 2, 2, 2. 2, 0, 1, 2, 2, 2, 2, 2. And then Z, X, Y, Z. Yeah. Velocity. Yes. Position. Yep. Positions. Wait. Oh my god. Here. I need to do for Z as well. Alright. Alright. Calm down. There we go. Now it feels a lot better here. Cool. Let's do the strafing as well. So that should basically be the same thing. I'm gonna move this out. You're the direction. The thing is, you would be negative. Right would be rotate. Now, the thing about rotate, though, is it has some stuff here. I'm not sure what this does. And we should be rotating by Y. So I think we could use this. Putting Y there. Angle is... I'm not sure if they're using degrees or radians. Rotates around an angle. Okay. So let's use degree or radians. So this would be 90 degrees. Just 90 degrees, yeah. And then I need to convert it back. But we could also... rotatio. Rotate by axis angle, whatever it's called. Now you actually need vector 3 angle, so this has to be a vector 3. And now we can say rotate. We need the axis as well. And move left is gonna be rotate. I mean, I guess we could just put in negative here, I think. Or, yeah, negative, I think. We need a dimension iterator. Yeah. Oh, that's... Okay, it works, but it's the wrong... It's apparently wrong direction. I'm probably... Yeah, I'm gonna kind of retrofit the physics system to not have... Why can't I move up here is the question. Can I move up here? Through this? No. Can I move sufficiently far away? Can make 3D game of life. I mean, yeah, the grid system could, we could do that. All right, maybe that's the last thing we could do here. I'm just gonna double check if I'm actually using the grid here. I think I am. Yeah, I'm using the grid here. It's just in some way it doesn't work. But yeah, we could do that actually. We could go the 3D game of life. We could do 3D game of life. I'm not sure how well it's gonna look because we don't have lighting. Should we do lighting as well? I do have a shader system, so I can... Or random colors. Shader, 3D... let's do a point light, maybe. WebGeo. Is this... This is like the old thing. I guess it doesn't matter. This is the fragment shader, right? I think. Or no. Well, I don't think we need to do this. Surface to light. Is that an output, like varying? Is that... I thought that was an input. Okay, and here's the fragment shader. We just do this. That was so simple. Compared to the other thing. Surface to light. Compute the vector of the surface to the light. Light world minus... So it's just a relative vector from the surface to the light. And then we have the normal and the surface to light. And we dot that to that. And that's the thing. Okay. What about... yeah, but this doesn't like include things like if it's far away, it like goes down. But I guess we could start here. 3D. Now we need to change a few things. This is gonna be gone. This is in. And then we have out final color. Guess that should work. Surface to light. We get the coordinate in here. I guess we could also get, I mean, we could just put the thing in here. We can just put the, wait, was surface to light? That seems so static. That's just one. No, that's one surface, or one shader, or one vertex, I mean. Because we don't have like a model. Okay. Actually, you know what? Raylib actually does this for us a little bit. I just remembered. Let's go to wait, shaders, basic lighting. Here we go. We could just go in here actually. How do I? Like how? How do I make a something to light up? Wait, create light? Wait, there is an actual thing called create light? I mean, we could just copy these shaders, I guess. Okay, this is the call your lighting. Remove the version because we defined that outside. All right, so that is the thing. Wait, define, does that actually work? Okay, we'll see. And then also FS. Wait, this was FS. God damn it. This is VS. Okay, I'm gonna. Now, let's do this. Open up VS. I'm gonna remove you. Switch you out. There we go. Now we have FS and VS. Alright, now let's go to Assets, Shaders, and we'll add lighting. And it's gonna be lighting club. Wait. All right. Now I'm gonna go to draw. We're gonna go to whatever we try to CRT. Actually, no. This should be like. Wait, is this? Yeah, this is meant to be used on like things, right? So when we draw the grid, not this grid, we draw this grid. Here I want to use enable shader for begin shader mode, lighting, and shader mode. You can't see the screen. Thank you for telling me. Not Slider. Welcome back, by the way. How's it going? Here for some 3D action. Okay, and now we don't see anything. Good. Good. Just off work. Nice. Getting home, relax. All right. Okay, and let's create. I guess we'll create like a light. Create light. Wait. There was no create light function. They're actually. Oh, what is this? Our lights. What is this? Oh, wait. Where are the functions though? Oh, they are here. Okay. So we have a light. Now where's that coming from? It's over here. Okay. And then we have shader values that we set on the shader. Right. Okay. Interesting. So interesting. I'm interesting. Like I feel like I'm interested. I feel like this is interesting because this shows how to create more than one light. We have 4 lights, but the shader is the shader. Here we go. It has max light. So the shader actually has all the lights in it. Okay. Yes. Typical end of day for Java corporate slave. Oh man. Yeah. Do you enjoy Java? Like, is Java like your favorite language? No. Kinda. Okay. Unfortunately, like in my area, there's a lot of like Java jobs, so I might actually be forced to learn Java. I mean, I know Java, but you know, professionally. 50-50, okay. Do you enjoy OOP? Oh, here we go. Anti-aliasing. Okay. Cool. Okay, but in the end, we need some kind of thing that's the light thing. So what I'm gonna do is I'm gonna go over back to the thing here. I will copy this, translate it into zig. I will make a light. I will remove a bunch of shit. Type is so this would be a light type, and enable is a bold. Position. Target. We don't use, I guess. It's like, okay, it's like it has like either point. We can actually make it a union E now instead. Attenuation. I actually have no idea what that is. I've heard it before, but maybe something to do with how much it falls off or something. Shader locations. Right. These. I don't remember what they are. I'm just gonna set like U32s maybe. Alright, and then we have light type. Current amount of created lights. Oh. Well, this could be replaced by just a bar size. And then we have a function, but this one Yeah, so this is a function, gives us a light. Light type. Position, target. Oh yeah, this is the other way around. All right. I mean, why are we doing it like this? Well, let's just do this. If this is more than or equal, unreachable. Panic. Too many lights. Otherwise we return. We also want it updated. Okay. But that could be like light update. So we'll move you here. Oh, and position is wait. Why? Oh, because it's not the correct thing. But now we can actually just use position here. And also this shader, we can actually have a shader key instead. And we can do, actually, we kind of need game. And enabled just enabled. Oh. I see, that's how you do it. Okay. Is that like an official, like, OpenGL way of doing it? Huh. So this would be light. Lights count. Oh. Well, let's have the index here. I guess it's more work doing it this way, I guess. Yeah, sure. Do I have get chain location on home game? It's U32? Oh, it's I32. Okay. I guess we'll do unreachable. But yeah, we need to do these up here. And we're gonna set value. I'm gonna actually You know what? Let's just do RL. Alright, but now we don't get the thing. Oh well, whatever. Uniform int. Uniform int. Just int. Okay. So essentially, this, but here we could just say position, because that's going to be kind of the same thing. You are the same thing, so we can just say self-target. Actually, it needs to be a pointer. And here's the color, which is in U8 format, I guess. Or is it? Yes, it is. And it needs to be in floating format, so from 0.0 to 1. Isn't there a convenience function to this? To HSV? No. Normalize. What the hell is this? Normalize it. Oh, this is the one we need. Okay. And then we just turn it into an array. So I guess we could probably just baitcast this to an array. Why don't they use that? Oh, whatever. Okay. Right, so this should be lights count now. You know what? We could just put that in here, I guess. So extend format buff plain search. Actually, we need a buffer here as well. And then go to here like this. Go to lights count. Huh? Oh, what the hell? Unused. Okay, sure. Wait. But this should be the actual shader now. And you are our zig+raylib. Right. Okay, there we go. We've translated this C thing. There we go. Into zig. Okay. Now we should be able to call this create light function somewhere. So I guess we'll do it here. Create light. Let's do a point. Why don't I get this thing? Okay, whatever. Position. Let's do like 0, 3, 0 or something. Target. Well, actually, let's do like in the actual middle, like 8. Target is no, actual middle will be 8, 8, 8. 8. 8, 8, 8, yes. And target doesn't matter because it's a point light, I think. So color, I guess we'll change to make a color shader key is lighting. There's something wrong with the LSP. Okay. And then the light we don't care about anything. Actually, we do wanna. I think we want the light stored somewhere. Let's actually create. Yeah, let's actually have a function here. Create light. I just realized now I have to get all these types in here. Light type, light mod, light type. Position. Target, color, and shader key. And game. Create entity. And add game create light type. Okay, something is wrong with LSP. I think I know why, because create light is like a constant. It's like an imported member function, so it doesn't really understand. Whoops, this is position. Target, color, shader. Yeah, there's something wrong with the LSP there. It doesn't understand. For LSP, it doesn't understand. Okay. And we just call create light. So now that it's created as an entity, so we can reach out for it later. When we need. Oh. Look at my fat fingers here. I can't type correctly. Expected 3 arguments found 2. Right. You also need buffer. There we go. Right, and then you are all I32, so U32, I32. U32, I32. Well, I'm not 32, so. Attenuation is not actually described here. I guess it's 0 then. Because that's what they initialized it to. Attenuation lock is not actually in here either, so I guess they forgot about attenuation. Attenuation. Is that actually in the shader at all? No. Position, target, color. But here we have a bunch of other shit. We have type enabled. Type enabled, position, target, color. Okay. Enable type, position, target, color, and attenuation. I guess attenuation doesn't exist. This is gonna probably be an error, so I'll just actually not have this at all then. And you need the actual shader. So yeah, we could get that. This is the actual key. And whoops, no, yes, you're the key. And the shader is get shader. No field name type. Yes, it's called light type because you can't have a field called type in Zig. And this one wants a pointer. There we go. Okay, there we go. So now we actually call this function to create a light. And I think this. Okay, now let's look at how they're using the shader, because we're not done with the example code here. So we've created a light. Now let's go down here. So they are setting a value which is the shader lock vector view, which is view position. Okay, so they are setting that every time. Okay, so let's do that. View position. That is something they have here. All right, sure. Let's go to, I guess that will be in draw. So set shader value, lighting, and this would be view position, and the position is just the camera, I guess, camera position. Yeah. So we can actually do like game from from raylib, which is not actually public. Let's make it public now. And this would be we need the camera. Camera position. Okay. So there we go. Now we're doing that. And here we enable some lights and we update the light values. Update lights are actually only enable disable. So the only thing happening here is the enable disable. Unless you want to change the color over time or something. We could do that, like hue rotation, you know, or blinking or something like that. But it seems like the only thing changing is enable saber. So we actually don't really need to do that. We just did it once and that should stick, I believe. Okay. And excuse me, as we can see here, the lighting shaders apply to all kind of models being drawn. So, oh shit. Okay, I need to fetch some paper here. I'll be right back. Okay. Crisis averted. Alright. So, yeah. I mean, that's pretty simple. We just do it here. I guess we could move it out as... I guess. We could do it essentially between... Yeah, I guess in this camera mode. And here we can end it after all this. No, not camera. End shader mode. Okay. I'm gonna not do this. It's kind of funny, but it's... Actually, it would be interesting to see if it actually gets like colors. And yeah, let's oh. Oh. So we're setting the value view position. We are beginning shader mode, drawing the things, ending shader mode. This one just draws them without color. It draws like the actual kind of like lamp thing. Drawing grid end mode. Oh, wait. Begin mode 3D. Oh, okay. We already do this, yeah. Draw FPS, text. Okay, I think that should be it here. So let's see if the lighting works. So much for that. Maybe it's because it's like above the grid and we are below, maybe. Let's put us actually like above a little bit. We are at 10, 10, 10. Let's put us up above the grid. Okay, well I can see kind of the grid. Okay. Where did the light be? Let's put this also at... Let's actually put the light right at the player. Let's check something else. Let's check if we actually need to put like some kind of, like, how are they, what are they, they're actually just drawing a cube here with white color. So that's the same that I'm doing. Interesting. I'm gonna double check if things shader compiled successfully. Why are there so many of these? Okay, well, I guess it should be good. First one is position, yes. Location, we update the lights. Should be enabled. Yes. Actually, we don't need index anymore. And don't get any warnings about setting the shader values. So, I mean, there might be some issues with converting here, maybe. But the other vectors seem to work when converting to just like an array. I think vector 4 also worked. Although this is a color, but this turns into a vector 4. Oh, Annie. Yeah, that looks correct. Looks like a reddish color. I'm just gonna double check the logs again. Shader ID 3. Program default. Shader ID 4546. I don't have this many shaders. Well, I don't know. Maybe it's doing something else that I don't know about. Okay, maybe these are like my shaders, perhaps, and the other one is like the built-in shaders. I don't know. Okay. Wait, directional is... it uses target, right? Is it because we don't create the other lights? What if we set 1 here? No. Because this goes through everything. So if we have like lights that are like have some sort of black color, it like overshadows everything else. And I guess these all come from zig+raylib here. All right. Is there anything else in here? I mean, I guess this one, but I don't think this does anything for this. I guess we could... Yeah, even if that isn't enabled, I don't think that should do much. We should still see the light, right? Wait, ambient. Wait. Oh, but that shouldn't do anything. Like ambient, we should still see the light, right? Oh, here is setting ambient to be 0.1. Wait, are we even setting the light? Wait, we're not setting the light. Oh. Yes. Oh, yes, we are. We are setting the light. Yeah, we are setting like light 0. Yeah. We are doing that. Except light count is added 1 here. Oh my god, okay. Okay, well that didn't do anything anyway. Let's do set shader value lighting ambient to 0.1, 1.0. That should give it an ambience, an ambient. It does work. So that's proof that the shader is like active. I mean, it was black before, so I guess that proves it was. If we do ambient like this, it should turn purple, I think. Yeah. So ambient is kind of like the minimum amount of light you could have. Or it's like an ambient light. It's like a light that permeates everything. And then this one sets a bunch of stuff here. We set all this stuff. Light type. I believe that's an unsigned int. I'm not sure if they... Well, unsigned and signed have the same format when it comes to positive numbers, though, so that doesn't matter. Yeah, position target, that should work. View position, ambient, lights, create a bunch of lights. Wait. Do we need to set this? Because... Or is it just a convenience thing? I mean, just cast it, man. Are you serious? Okay. Okay. Is that really... And then here, Yeah, sure. I mean, that has to be the same thing. Yeah, I didn't think that would do anything, but yeah, okay. Also, the position, look at the position is, when we go down, it is going down. So actually, more Y means further up. Yeah. So the light starts same place as the player. Let's, I guess, we could move it down. If we move all the way down, where are we? We're at 14. So it's like right about here. Let's do like 14.1. Just to make sure there's no issue with like the closeness of it. Actually, you know what? Here it's kind of weird because we don't actually see the cubes and the plane. So what's going on with this example actually? This example doesn't even work. It's supposed to draw a cube and a plane. Well, we can't see it, so I don't know what's going on there. Where is the grid? The grid is drawn after, so it's like the grid is like on top of everything. We don't even see the... Oops. See if we can find something else. Fog. This has to have some kind of lighting. I mean, I'm seeing... Maybe it's like directional light. Yeah, look at this. It does have lighting. Here they're working with models. Oh, they are just using the lighting shader. So they're using the same shader here. Well, I guess for the vertex, the fragment shader is fog. Right, have the same kind of... implementation for lights. But here we can actually see the things. I am confused. Okay, but I'm out of time, so I think we'll continue this next time. But yeah, this was a fun little venture. I wish I could make some more progress. Maybe next time we'll look at getting in Box 3D and being able to like move around in like an FPS environment or something like that. So, but yeah, that's gonna be it for this time. So thank you very much for watching, and hope you have a nice day, and I'll see you later. And let's send you off somewhere. Good old pixel art. Is there anyone doing like zig? There's never anyone. No one has ever. Oh, but this is in French. Yeah. Is that okay? I don't know. Gento. Det gör vi. Okay, I'll send you off here. I hope you have a nice day. Bye bye.